Good morning, guys. Today's lesson is 5.13 Experimental Design. The aim is how could we identify and describe different types of experimental designs. So today's due now. The researcher finds 200 individuals where 100 of them have eaten organically for the past 3 years and the other 100 haven't eaten organically in the past 3 years. They then give each subject an overall health assessment. Lastly, they analyze the data and use it to draw conclusions on how eating can affect one's health. So what type of study was this? And be sure to explain your response. Come back when you're done. We'll review it together. So this is a case control. Why? There are two distinct groups focused on a single characteristic. In this case is eating organically. In addition, this is a retrospective survey, so those are thinking like past, present, because they're looking at eating patterns to generate an association between eating organically and being healthy. Now, we're going to discuss today the different types of experiments. Observational studies, right? The question I got a lot was case control versus cross-sectional. So the way to remember it, or I'm sorry, cross-sectional and cohort. Way to remember it is cross-sectional is one group, instantaneous time, a very specific time period. Cohort is one group, but it's over an extended period of time. So a cross-sectional would be you're going to use this group and you're going to look at this date or this day or this month. Cohort is I'm going to take this group and I'm going to look at this group over the course of a year or 2 years or 6 months. All right. So moving forward, experimental design, the process of designing an experiment, right? So let's talk about these words because these are some definitions that are specific to this idea. Number one is causation, right? That's the actual relationship between cause and effect, and it's also the word causality. Now, remember, we talked about some observational studies. You actually can't prove causation. You can only see associations. In other words, you could see that it appears to be a relationship, but you can't confirm it. In experiments, you can confirm it. You can confirm that this leads to that, and that's what causation is. Now, control, right? This is a new word. You may have heard it, but what a control is, it's the portion of the experiment that remains the same, and it's used to analyze the effect of the treatment. So the control group is the group that has nothing changed. And then the treatment is the variable being altered in this experiment. So we use the control to see the effect of the treatment, which is the variable being altered. All right. So the three main types. Now again, there are so many subtypes of experimental designs. I want to just expose you to the three main ones. This is really helpful, especially with what's going on lately, because with COVID-19, a lot of observational studies and experiments are in the process right now, real time, trying to figure out cures or vaccinations, as well as like interactions between different drugs and other diseases and this virus. So, first one, right? Completely random design. So I have a group of 1,000. I'm going to randomly assign them to a control group, which is our placebo, and our test group, which would be like our vaccine. No emphasis on how they're organized. We're just going to take 1,000, randomly select 500 of them, you're in the placebo group, or randomly select 500 of them, you're in the test group. And even those, right, control and test are randomized. You don't know which group is going to be what until you assign them. Now, randomized block, right? This experiment divides participants into subgroups called blocks. So a block is just a group. It then randomly assigns them to a group. So, what does that mean, right? So let's take those same 1,000 people. But now what we're going to do is we're going to break it into male and female. So half the males get the placebo, half the males get the vaccination. Females, the same thing occurs. At every point, it's random. So once you break them into groups, male and female, who gets the placebo, who gets the vaccine is randomized for each one. So you don't know. This is a really helpful experimental design because not only will it show you the cause and effect, but it'll show you whether or not it differs amongst different populations. And now last, this is a little tricky. So it's called the match pair design. So this is a special case of a block. And it's only used when there's two treatment conditions. So what I mean by that is either a vaccine or a placebo. Because what could happen is some experiments can give you like different levels of the vaccine. So one group can maybe get half a dosage, another group can get a full dosage. This would not, a matched pair would not occur then. This only occurs when it's two options. Now what happens, right? We still have the same 1,000 people, but now they're broken into pairs. So pair one is two people. One gets the placebo, one gets the vaccination at random. Pair two, one gets the placebo, one gets the vaccination at random. And it goes all the way until 500 pairs, right? Because 500 pairs would be 1,000 people. One placebo, one vaccination, completely randomized. All right. So similar to how we did the observational studies, today's about identifying which type of experiment was done. So here's the guided practice problem. A study took a group of adults and randomly divided them into two groups. One group was told to drink tea every night for a week, while the other group was told not to drink tea that week. Researchers then compared which group fell asleep. What type of experiment is this? Explain your response. So, this is a completely random experiment. There was no pairing, right? We didn't see a pair of two, one drink tea, one not, and there was no blocks, right? We didn't break it down into male, female. We didn't break it down by age. We didn't break it down by race. All we did was say, here's a group of people, randomly divide them. One, you guys drink tea, you guys don't drink tea. Let's see what happens. So, three problems, three scenarios. Again, all you're going to do is describe which experiment was done, explain why. That's all for today, guys. Have a great day. We're going to spend a couple more days on this, so don't feel overwhelmed. Take care, and obviously, reach out if you have any questions.